affect the pressure on a gas sample? Most of these ideas you should be really readily familiar with. So first off, if we change the number of moles of gas, how does it affect the pressure? So when we look at our first container, this represents about 3 moles of gas. And when we move to the second picture, now we have 6 moles of gas. So when you look from first picture to second picture, we see an increase in the number of moles of gas present in the container. And because there's more particles in the container, we would expect an increase in the number of collisions. And pressure is the result of collisions. So if we have more collisions, then we end up with a higher pressure value. Taking a look at the second factor that we can manipulate, changing the temperature of a sample of gas. So when we look from picture 1 to picture 2, we start at a lower temperature and we go to a higher temperature. So we see an increase in the temperature, which means we are increasing the average kinetic energy of every particle in the sample. So they're moving more and faster. So the faster the particles are moving, the more likely we'll see an increase in the number and frequency of the collisions. More collisions means a higher pressure value. And the third factor that we can manipulate in the lab is to change the volume of the container that's holding the gas. So when we go to picture 1 to picture 2, okay, we notice a decrease in the container's volume, which now reduces the space between those particles. So each particle has less room to move around in, which will then increase the number of collisions. And as a result, more collisions, higher pressure value. So pressure is the result of collisions. More collisions, higher pressure.